The purpose of this channel is to help you understand the concepts of physics. I have made it very simple, so anyone can easily follow these lessons. Let's get on with today's lesson. In this lesson, we are going to look at the motion of an object in a straight line. The physical properties of an object in motion are studied under kinematics and dynamics. Both kinematics and dynamics are two branches related to motion, categorized under classical mechanics. The third branch under classical mechanics is statics. In statics, the object does not move, and we study the forces under equilibrium. I will discuss statics and dynamics in another video. In kinematics, we study the motion of an object without an external force. In dynamics, we study the behavior of an object when an external force is applied. Examples for each category are given in these two charts. Under kinematics we have speed, velocity, acceleration and displacement. Under dynamics we have force, torque, momentum, energy and work. With that brief introduction to classical mechanics, let's look at the motion of an object in a straight line. These three vehicles move in the same direction. Vehicle A starts from rest and moves with a constant positive acceleration. Vehicle B moves with a constant velocity. The acceleration of vehicle B is 0. Vehicle C moves with a constant deceleration. Therefore, its acceleration is negative. The velocity time graphs show the movement of these three vehicles. The gradient of graph A is positive because the vehicle is moving with a constant acceleration. The gradient of graph B is 0 because the vehicle has no acceleration. It moves with a constant velocity. The gradient of graph C is negative because the vehicle is moving with a deceleration. The distance traveled by each vehicle is given by the area under the curve. Now, let's look at the motion of an object, which has an initial velocity of u, meter per second. This object moves along a straight line and reaches a velocity of v, meter per second, after t seconds. The motion of the object is given in this graph. Like in the previous example, acceleration is given by the rate of change in velocity. We can derive this formula when we substitute the given parameters. Finally, we can derive this formula after rearranging the parameters. Let's call it equation 1. The displacement of an object is given by the average velocity times the total time taken. Or we can take the area under the curve to calculate the displacement. We can derive this formula when we substitute the given parameters. Let's call it equation 2. Now we can substitute the value for v from equation 1, which gives this formula. After rearranging the parameters, we can derive this equation. Let's call it equation 3. Using equation 1, we can derive a formula for time. We can derive this equation when you substitute for time. After rearranging the parameters, we can derive this equation. Let's call it equation 4. These four equations are called kinematic or Suvet equations. These four equations will come in handy when you attempt to solve questions related to kinematics. Let's look at a question and apply what we have learned so far. A vehicle that has an initial velocity of 10 meters per second moves with an acceleration of 6 meters per second per second. Find the displacement of the vehicle after 3 seconds. Let's list the Suvet values. We have to find the displacement of the vehicle after 3 seconds. The vehicle has an initial velocity of 10 meters per second. But we do not know the velocity after 3 seconds. This velocity is not required to find the displacement of the vehicle. The vehicle is moving with an acceleration of 6 meters per second per second. We can use this kinematic equation to find the displacement of the vehicle, after 3 seconds. We get this expression, for displacement, when we substitute the Suvit values in the equation. We can calculate the displacement of the vehicle, as 57 meters. I hope the answer was clear. Let's look at another question. A vehicle starts to move from rest. It reaches a velocity of 10 meters per second in 5 seconds. It continues to move at the same velocity for another 5 seconds. The vehicle comes to rest, with a deceleration of 5 meters per second per second. First, we need to find the acceleration. Next, the total travel time. And finally, the total displacement of the vehicle. Let's solve this problem together. First, we need to draw the velocity time graph, and plot the given data. The acceleration, or the rate of change of velocity, is given by the gradient of this line. Take any 2 points on the line, let's calculate the gradient. Let's take these coordinates, to calculate the gradient of the line, as shown in the graph. From this equation, we can calculate the acceleration, as 2 meters per second per second. We know, both the time taken to accelerate, and the time taken to travel with a uniform velocity. However, we need to know the time taken to decelerate, in order to calculate the total travel time. Let's use this formula, to calculate the time taken to decelerate. We can calculate, the time taken to decelerate, as 2 seconds. The total time to travel, is the sum of time taken to accelerate, time traveled with a uniform velocity, and time taken to decelerate. However, both time taken to accelerate, and the time travel with a uniform velocity, are given in the question. Just now we calculated the time taken to decelerate. Therefore, the total time taken, for the entire journey, can be calculated as 12 seconds. The total displacement is given by the area under the curve. We know this, from the previous lesson, which is the sum of, area A1, area A2 and area A3. We get this expression, when we substitute the values for area A1, area A2 and area A3. We can now calculate, the total displacement of the vehicle, which is 85 meters. The purpose of this example, was to help you understand, the method of calculating velocity, time, acceleration and displacement of a moving object, and to get familiar with the 3 equations, that we derived at the beginning of this lesson. However, I recommend you to use the time-related graphs, as much as possible, to solve problems related to motion in a straight line. In the next example, we will see how to calculate these values, in relation to another moving object. Let's solve this question together. 2 vehicles, A and B, move towards each other from a distance of 93 meters. Vehicle A reaches a velocity of 6 meters per second, in 3 seconds, and continues to move in the same velocity towards B. Vehicle B starts to move towards Vehicle A, after 2 seconds. Vehicle B reaches a velocity of 8 meters per second, in 2 seconds, and maintains this velocity throughout the rest of the journey. You need to calculate, the time taken for both these vehicles to cross, and the distance that these 2 vehicles have traveled, before they cross. Like in the previous exercise, first we need to draw the velocity time graph. The 2 vehicles are going in the opposite direction. Therefore, when we draw the graph, we need to be mindful of the direction of displacement, and velocity. In this graph, the displacement of Vehicle A, is drawn in the positive y direction, and the displacement of Vehicle B, is drawn in the negative y direction. Vehicle B starts to move after 2 seconds. Therefore, in the velocity time graph, movement of Vehicle B should start after 2 seconds. Please comment below if you have any questions regarding the XY quadrants used to draw the graph. Let's take t as the time taken for both vehicles to cross. When the two vehicles cross at time t, the combined distance traveled by both vehicles should be equal to 93 meters. This can be written as shown on the screen. We can calculate the displacement of both vehicles, at time t, from the area under each graph, which is shown in the graph. We can rearrange the expression, taking time as the subject. Now we can calculate the value of t, in seconds. We can use this value of time, to calculate the displacements of the two vehicles. Let's use the two expressions, that we derived for the displacement. When you substitute the value of time, we can arrive at the displacement of the two vehicles, as given on the screen. Let's look at another question, with two moving vehicles. Let's solve this problem together. Two vehicles A and B start a journey from the same point, at the same time. Vehicle A starts from rest, with an acceleration of 16 meters per second. It accelerates for 4 seconds, and maintains a steady velocity thereafter. Vehicle B starts with an acceleration of 8 meters per second, and continues to maintain a steady velocity after 8 seconds. We need to calculate the distance between the two vehicles, when they both reached a steady velocity. Let's draw the velocity time graph for the motion of the two vehicles. Vehicle A travels with an acceleration of 16 meters per second, for 4 seconds. We can calculate the velocity of vehicle A, by taking the product of acceleration and time. We can follow the same method, to calculate the velocity of vehicle B. The graph shows that the two vehicles maintain a steady velocity, after the 8th second. Therefore, the velocity of vehicle A, relative to the velocity of vehicle B, is 0 after the 8th second. In other words, the distance between the two vehicles will remain unchanged, after the 8th second. The difference in displacement of the two vehicles just before the 8th second, is the distance, that the two vehicles will maintain, from that point onwards. Let's take S, A, as the displacement of vehicle A, till the 8th second. We can take the area under this curve, to calculate the displacement of vehicle A. We can apply the same method, that we used before, to calculate the displacement of vehicle B. Now we can calculate the difference in displacement, of the two vehicles. This gives the gap, that the two vehicles will maintain, after the 8th second. However, we can calculate this gap between the two vehicles, by calculating the area shown in the graph. This is another method, to calculate the distance between the two vehicles. I hope this lesson helped you to understand the concepts of motion, in a straight line. Please check my next video, for more examples in this section. Please subscribe to this channel, that will encourage me to make more and more videos on this subject. If you found this lesson useful, please leave a comment below. Please don't forget to press the bell icon, before you move out of this channel. Let's meet again with another video. Bye.